This is question 3 from the 2011 mCAT exam. First thing we have to do is factorize. Especially when you've got two terms like this, generally what you're looking for is what the two terms share. AB squared means an A and two B's. A squared B means two A's and a B. So they each have one A and one B. So we factorize those from the two terms. We took one A and one B out. We have a B remaining. We took one A and one B out. We have an A remaining. And that's all. For part 2 of question A, we have a quadratic. The way we factorize quadratics is we have two sets of brackets. Each of them starts with an x. What we're looking to do is put two numbers into these brackets that together multiply to -5 and add to -4. Since they multiply to -5, we know one must be positive and one must be negative. Two numbers that add to -4 multiply to -5, those are -5 and +1. 1 minus 5 is -4. 1 times -5 is -5. So that's our factorization. For question B, we can see question B is very much related to question A. We solve this in largely the same way. We start with what we did question A part 2. We factorize. Only this time we have equals 0. The only two ways to multiply and get a 0 is if either the first one is 0 or the second one is 0. So this tells us either x plus 1 equals 0 or x minus 5 equals 0. One of these must be true. We solve each one for x. What can you add 1 to get 0? That would be -1. What can we subtract 5 from to get 0? That would be 5. So x is either -1 or +5. Now, if you factorized problem A, part 2, incorrectly, but then used that incorrect factorization to solve this problem, and the rest of your work was correct, you can still get achieved on this problem, even though your initial work was wrong. Part C of question 3 hopefully looks very similar to you, to parts A and B. We still have x squared minus 4x minus 5. We're trying to simplify this fraction. Now what's tempting for many students is to do things like cancel the 2x squareds. You cannot cancel things from the top and bottom of a fraction as long as you have addition. The only way that works is if you have two things multiplied together. So we do need to factorize this first, which means that parts A and B were a big hint on how to solve part C. We've done this already. For the bottom, we need two numbers that add up to 6 and multiply to 5. Those had better both be positive. And it turns out 1 and 5 add up to 6 and multiply to 5. Doing that much will get you achieved on this question. Doing this much will get you merit. Part 2 of C is again just like part 1, we're going to do the same things. We know that this reduces, because we just did it, reduces to x minus 5 over x plus 5. Now, on this question you can get excellence. We realize that we need to, since we are dividing by x plus 5, we need to multiply both sides by x plus 5. Multiplying by x plus 5 and dividing by x plus 5 will cancel each other out. And we have our x minus 5 still. And on this side we need to distribute. 2 times x is 2x. 2 times 5 is 10. Now we have a situation very similar to what we had in question 1, 1a part 2. We have x's on both sides. We need to get rid of one of them because we can only have x in one place in order to solve. X minus x is 0. Don't forget your negative. 2x minus x. X by itself means 1x. So 2x minus 1x is 1x. Plus 10. Almost done. To have the x by itself, we need to get rid of this plus 10. So we subtract 10 from both sides. Plus 10 and minus 10 cancel. That leaves you with your x. And negative 5 minus 10 is negative 15. And getting to that part will get you excellence on this question. For part D, we have a situation where we're modeling the path of a ball as it falls. Now, things fall in parabolas, and since it's falling, we end up with this negative t squared. That gives us a parabola that looks like this. What we're trying to find, how long after it is thrown will the ball hit the ground? That means, if it's on the ground, the height has to be 0. Now, because of this negative, we need to do some special considerations. The easiest thing to do here is say, I don't like having a negative t squared. So I'm going to take this negative and bring it away from everything. Take a negative out of the t squared, and we have just the t squared left. Take a negative out of the plus 6t, and you have minus 6t. Take a negative out of the positive 7, and a negative 7. And this is something we can factorize relatively easily. Again, 2 sets of brackets. Each one starts with a t. 2 numbers which add up to negative 6 and multiply to negative 7. Those are negative 7 and positive 1. And then, just like we did before, these 3 things multiplied together must be 0. A negative can't be 0. So it must be either t minus 7 equals 0 or t plus 1 equals 0. This one says that t equals 7. This says t equals negative 1. Now we're trying to figure out how much time it took after it was thrown for the ball to hit the ground. That answer can't be negative 1 seconds. So the answer must be 7 seconds later. We already have our factorization. We're trying to figure out how much higher this ball goes from where it was thrown. We need still h equals the same thing we had before. One of the ways we know to find the highest point on a parabola that's facing downwards is it's exactly in the middle of the two zeros. Our zeros, we already saw, were at positive 7 and negative 1. Those things are 8 apart. In the middle of them is 3. So it will reach its maximum height at 3 seconds. So what we need to do is find the height. That's h of 3, in other words, the height at time 3. We just put 3 in wherever we see t. Three minus 7, 3 plus 1. And the negative of negative 4 times 4 is positive 16. So our maximum height is 16 meters. Now, as it turns out, that's not what the question asked. The question is, how much higher does the ball rise above the height from which it is thrown? We look back at our original equation and we see that 7 is our initial value. When t is 0, that's 0, that's 0, we end up with 7. So we go back and we say, if it gets up to a height of 16 meters, then that is 9 meters above. Where is the